The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.
All right, on three, we're gonna open the door and blow them to Kingdom Come. Are you ready?
Yeah, I guess. This is so stressful. I don't know why I agree to these weekly Nerf fights at Backflip Films.
1, 2, 3.
Guys, come on, what's going on? We got a client coming in 5 minutes. Who's gonna help me pick up? Where'd they go? That doesn't even make sense. What? You know what? I'm gonna text Ben. He always knows what to do in these situations. Okay, here we go. Dear Ben, I know you're busy, but I was wondering if you could drop everything you're doing right now and find a solution to a problem I'm having.
Sure, Ryan. What's the problem?
Well, here's the thing. We have intense Nerf battles every week, wink. And I'm always the one who ends up having to clean up all those loose darts that are left on the floor. Any way you could create some sort of magical Nerf dart collecting robot?
I don't know about magical, but we could use the iRoomba Create Kit to make a Roomba that rolls around looking for darts using vision tracking and then scoops them up into some sort of custom dart collector cartridge. Let's get started.
Amazing hacks.
How can we make this portable?
Inspired designs.
I am the internet troll.
Regrettable acting.
Batten down the hatches!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
We're going to embark on a multi-episode quest to help Backflip Films solve their Nerf dart problem. The people at iRobot were kind enough to send us the iRobot Create Kit, which is a refurbished Roomba that comes with a data cable and is intended for educational and experimental use. You can communicate with the Roomba via serial. And with that serial port, you can control all of the functions. You can make it move around, you can make it beep, you can tell it to go back to its charging dock, and you can also get all the sensor data. The Roomba has a lot of automatic functions built in that keeps it from going off cliffs or running into your cat, but you can control those things manually if you want. Our first goal will be to control the Roomba with a microcontroller unit because of course we want to make an all-in-one embedded solution. But to get to that point, I think we'll test it and test the commands using a PC and a standard serial cable that came with the iRobot Create Kit. You've got the Roomba charging on its dock and it's connected to this computer using the supplied USB cable, which I assume was just some sort of FTDI USB to serial adapter.
Yeah.
But it was nice of them to send that. So we have a terminal program here that we can use to send commands. Now this is what you printed off the internet. So this is the Create to Open Interface specification based off the iRobot Roomba 600. Basically what you get out of here are a lot of opcodes. And by sending these bytes over the serial port, you can tell the Roomba to do things. For instance, if you want to control it, you send a start command. And then there'll be usually parameters. So you send an opcode is like what I want you to do. The parameter is like how I want you to do it. So drive forward at this speed is an example of what you might send. So what we're gonna do is we're gonna punch some of these opcodes into this terminal program as macros so that we can do one-click sends using the computer. And we just wanna make sure everything works before we switch to microcontroller. All right, I'm gonna change it to the 128, 131, which is basically gonna be like, okay, we're gonna start talking to you and then we want you to go into this particular mode. Okay, let's try to connect to it. Yeah, okay, ready?
Yeah.
Oh, there we go.
Yeah.
Now we're connected. When you disconnect from the Roomba, it basically puts it back into its normal operating mode. Okay, let's try a drive command then, see if we can actually talk to it.
So 145 is direct drive.
Okay, I'm gonna create a new macro. All right, so 145, what's next?
And then you need to send 0, 200, 0, 200. Actually send it 020 and 020 so it'll go slow.
Okay, I'm gonna connect to it and then try to send it the move command. Okay. Get ready to grab it.
Are you saying it 200 or 20?
20.
Okay.
Ready?
Yeah.
Oh!
It's still pretty snappy.
It looks like, hold on a second. I'm gonna send the start command, lift it up, Oh, see that how the light came back on? So if it's in safe mode and if it detects any sort of problem like a cliff or a wall, it immediately cuts control and goes back to its normal operating procedure. If we went into full mode, it wouldn't do that, but we don't want it to fall off the table either. Actually, we should do a test. We should make it move forward again and see if it'll stop before it goes off the table. So pretend you're like Aaron Rodgers and get ready to receive the ball. And you're dating Olivia Munn, it's even better.
Yes.
Okay, let's see if we can get it to, all right, ready?
Yeah.
Oh!
Was that safe mode?
That was like a lemming. I think it was, although I think we have some other communication problems, but we can definitely send it commands with the serial port, that's good. According to the data sheet, we can look at the buttons as one of the sensors. That could be handy. We could basically use this and say, okay, do what you're supposed to do.
Yeah.
Do what must be done. That way we don't have to add buttons. Let's do a few tests though. Take it off the charger. Okay.
It's gonna want to dock now.
Okay, yeah. All right, I'm gonna connect to it, which should turn off the clean light.
All right.
Okay, now we're in control. Now try hitting buttons and see if it reacts. Okay.
This is safe mode?
Yes, so in safe
Okay.
mode, even though it's got cliff detection and the other safety features, see how it goes back into its normal mode when you did that?
Yep.
The buttons aren't being checked, so that's handy. We could use those in our program. So the Roomba can detect cliffs. There's IR bouncers up here. There's actually 4 of them, so if it goes off a cliff, basically if the IR doesn't bounce back, it can turn around. It also has wheel drop sensors. If you look at the wheels, they're spring loaded, so it knows when the wheel has dropped. What is the auto dock command?
Let's see.
Do you remember? Seek dock 143. All right, let's see if we can make it find the dock. I'm going to connect to it.
Okay.
Something we need to think about is if this is the front, it's gonna roll over the darts as it collects them.
Yeah.
Well, there's a dart over there, could you grab it? So that's where we need to collect it at. And we might hit it there, but it should be okay. Actually, let's do this. Put it over there. Let's make it roll over darts in order to get to its dock. So this thing basically would be pretty useless if you had kids at all. Didn't you love all those ads for Microsoft Connect where everyone had like perfectly clean living rooms that were 30 feet wide to play Connect in? Seems to have some trouble making it over these darts. It could always back over them, but then we wouldn't have the front and cliff infrared sensors. What the infrared sensors do is they send out an infrared beam, and then if that beam bounces off something, the detector can see that, and therefore it knows it's an object. Don't you have a disassembled Roomba over there? Let's take a look at that. Because this would be the front right there. So it's got 6 light sensors or infrared sensors in the front. Then there's 4 cliff sensors, 1, 2, 3, 4. Left and right bump sensors. Okay, so that's quite a bit. But that all assumes it's driving forward. I mean, driving backwards,
You got nothing.
it's blind as a bat. I guess the trick is driving over darts. You know what we should see is how far the wheels have to drop before they're considered to be dropped. Can you get the laptop?
Yeah.
Let's put it into command mode, and then we'll try to drop the wheel. Okay, I'll drop the wheel. Okay, there it goes. Oh wait, you can hear it. Can you hear that?
Yeah.
That's pretty close to the end of the stroke. Looks like the normal height is just under 3/8 of clearance. And to get the rubber tip of the dart with clearance is more like, 5/8 would be a better clearance. You can lift up the back quite a ways, and the wheels actually don't hit the switch until they're fully extended, which means, we could lift kit it, but the front wheel doesn't move, see that?
Yeah.
And that's what would drive over it. So that's where we need the lift, and that's the hardest place to achieve the lift, of course, because why wouldn't it be? This wheel probably has a photo sensor under it, so it can see the changes from black to white as some sort of rotary encoder. We have an extra Roomba. We're gonna take its rotary wheel apart and see what we can find.
Looks like maybe we could have some spacers in here and longer screws.
That could work. Yeah, it looks like this has a continual brush on it. And then these wires here, so you got black and red means some sort of LED emitter, and these other ones are probably a detector. So I'm pretty sure that it's basically looking at the color change with the optical sensor under there. So there's screw posts, you're saying?
Yeah, right here.
Oh, okay.
There and there. Well, how far does it need? How much clearance does it need?
Yeah, that's what we should measure next. Okay, I want to say 1/4 inch, because it's stock 3/8. Sorry, we're not using millimeters, everyone. Yeah, it's just under 3/8. And then to really get clear of it, yeah, so 1/4 inch. Oh, we just use a nylon spacer.
Yeah.
We already have those. All right, grab the bin. Okay, let's take this apart. I'm sorry, Roomba. You became sentient and we had to take you apart. What we're gonna try is replacing the screws that did hold this encoder wheel in place with slightly longer screws and a 1/4 inch spacer that should drop the wheel lower. I think we need like a rear idler wheel now, Felix. 'Cause now see how it's drooping in the back? Got like a bad suspension. Let's see if it can still move around like this though. Maybe we've just, crippled it beyond repair. Also, these might not engage. Uh-oh, grab it. Flip it over. All right, we've got to make these prongs higher. Man, it's not one thing, it's another.
Perhaps we could just lift the whole entire base.
Or space it, you mean?
Yeah.
Oh yeah, grab a piece of foam core. That'll probably do it. Nope, we're gonna have to raise the prongs themselves. It's time for a tech timeout. Fly into space! At the 2014 Detroit Maker Faire, we picked up one of these CMC Orion Delta 3D printers. And I tried working with it, but I had a lot of trouble getting good, consistent results out of it. So this year at the 2015 Detroit Maker Faire, I was given the advice to use matter control software. So when I got back home, I downloaded it and tried it out, and I have had really good results. And there's a built-in setting for this printer in the software, which really helps. Some other things I've done to improve it, or at least make it work the way I want it to work, is I put Captain Tape on the glass. Some people swear by glass for 3D printing, but I don't like how you have to put glue sticks on the glass to make the print stick, because then you have all this glue stick residue that piles up and gets thick fairly quickly. I prefer Captain Tape and a quick shot of hairspray. Also, I noticed these had some jitter to them. Now there's wheels here on either side that go into the grooves of the extruded aluminum. And that's all well and good, but I didn't feel they had a very good grip. So on one side of each one of these arms, I 3D printed new wheels that had more of a V groove, so they would bite into the aluminum. And I don't know if it's really improved the print quality that much. I mean, it's been consistent, so maybe it has, but these are very rigid now. They only go up and down, they don't jitter left and right. So I guess the moral of the story is, if you have a piece of equipment that's not quite working for you, don't give up on it, it just takes time. The charge prongs need to go higher in order to reach the lift kit Roomba. We dremelled out the holes so they're allowed to spring up higher than they were before. Let's try it again. Give me some blue masking tape. I've been dead once. It's very liberating. You can call me Joker. What? And as you can see, I'm a lot happier. Go. It sounds so proud of itself. We cut the holes for the prongs pretty wide, so now we need to encapsulate them. I'm going to 3D print black ABS caps so they can hold the prongs at the right height to engage properly with the Roomba. All right, let's see if it'll still engage. I think I might have to reprint them again. Can you break those off of there, Felix?
Yeah.
We did some experiments and we found that the Roomba communicates better with a microcontroller than it does over the USB PC connection cable. Anyway, Felix rigged up this, we just use a stock Arduino with a board here. So this basically takes the battery power coming off of the Roomba, knocks it down to 5 volts, drives the Arduino. So we can use this as a test brain. We'll obviously build something nicer into it later on, but this will work for now. So I think what we should do, Felix, is send some sketches over and see how many commands we can get to work.
All right.
All right, let's see. Serial sequence is 145, which is the opcode telling it to direct drive. Right velocity high byte, right velocity low byte, left velocity high byte, left velocity low byte. And the range is -500 to +500. So for this, we want to make sure we actually use a signed integer. Sometimes you see signed to unsigned in code, and that means if it is a negative number or not a negative number. So to get -500 to +500, we will need at least a word, and that's why it has high byte, low byte. So you'd be sending it a word which is 2 bytes, and you send it the high byte, and then the low byte, the high byte, and then the low byte. Our serial commands send everything 1 byte at a time, so we'll actually have to take the 2 byte word and chop it into 2 pieces and send it in a row. So I will take a look at that. Okay, I've created a function called direct drive.
Okay.
And we have 2 numbers going into it. A signed short, usually it defaults to signed, but I just want to make darn sure that it's a signed short. Left velocity, and then signed short right velocity. So first we send the opcode 145. That means that, okay, we're gonna send you velocity. Let's see, Roomba serial. We have a separate software serial port for the Roomba, that way if we want to talk back to the computer and get some information, we can. Oh, and then it's right. Okay, so right velocity, bit shift 8 to the right, which will put the high byte into the low byte. And whenever you send a single byte command, it's always sending, even if you put a word into a byte command, it'll always send the lowest byte. Then we'll send right V and FF, which will basically mask off the high byte. And then we'll do the same thing for the left. So we're taking a 2 byte word that is signed, we're chopping it up into 2 bytes and then sending them both in serial. Okay, looks like this direct drive thing should work.
Yeah, and the -500 to 500 translates to millimeters per second.
Okay. Okay, now I am typing in direct drive. Let's see, direct drive, let's do 100, 100. Does that sound safe? About 1/5 total speed.
Sure.
All right. Do that for 1 second. And then stop. And stop for 2 seconds. Okay, let's plug in the programmer. So Felix is going to be the spotter for the Roomba, and I will send the code. Okay, that works. I want to pick it up. Okay, let's try a negative number. You know what? Let's speed it up. Let's go full speed. Let's go 500, 500, -500, 500.
All right.
Sometimes you have to run before you can learn to walk. Okay, I'm going to reduce the amount of time it goes that speed, but yes, it could fall off the table. All right, you ready for some action? Yeah. Here we go.
It's burning out.
All right, pick it up. Okay, let's try to make it go in circles. To make it go in circles, we will move one wheel in one direction and one wheel in the other direction. I'm going to reduce its speed, though. I think it's just becoming too much of a hot rod. My brand new Roomba does 185. It lost its license, now it don't drive. It's so dumb. There, let's complicate its life. It's gonna have to deal with this on a daily basis. One of the sensors we want to use is the rotation sensor, which allegedly tells you how much the Roomba has rotated since the last time you pulled the sensor. So let's give it like a reference grid here. You know you can allegedly make an entire pole shed using just a speed square.
When you need like hammers or something too?
Oh, he just go like that. All right, start him with his nose on 0. So we're gonna send a simple loop. We're gonna tell it to rotate at a velocity of 100 millimeters a second for 1 second. So I guess that would, in theory, get you 100 millimeters, although I doubt it'll be exactly 100 millimeters. And then every time it moves, it's going to report how many degrees of angle it thinks it's rotated. So we can double check that with our drawings there and see if it's remotely what we expect. We measure the diameter between the Roomba's wheels so we can figure out the circumference of its turns. We're going to look for what the 45-degree turn number should be. We calculate it to be around 97 millimeters of movement. So we're gonna try a few different things. 97 seems a bit high. Looks more like 95 is where we need to be because we're consistently getting a real world 45-degree turn when we type that in. We can double check this by typing in twice the value of 190, and that will move the same distance or rotate the same distance at twice the speed. So that gives us a pretty good number for when we want to turn around or turn 90 degrees or whatever else we need to do once we actually program this thing. Let's recap what we've done so far with the Roomba. We established a connection over the serial port. We sent it commands and we also got back sensor data. You can pretty much see everything that the Roomba sees. We added a lift kit so it could roll over the Nerf darts. And we did some math to determine the linear millimeters that you needed to achieve turns based off how you're moving the wheels. This is a multi-part project, so we'll be returning to it in a future episode. What we need to do still with the Roomba is build a dart collecting cartridge. That'll probably be the most complicated part of the project. We're basically going to take out one of the vacuum cartridges and build our own cartridge that can pick up the darts. Then we're going to use a camera to detect the darts, so it'll look around on the floor, see a certain color dart, and then we'll write code so that once it sees the dart, it will drive to it, drive over it, scoop it up in the vacuum cartridge, and then look around for more darts. And it'll keep doing that until there's no more darts, and then it'll go back to its charging station. That's all the time we have for today. In our next episode, we're gonna take a break from this, as I mentioned, and work on an oscilloscope watch and make it using the Formlabs SLA 3D printer. We'll see you next time.
There's no way I can do this myself. I need a robot or something. That's it. My hands are full. I guess I'm done. Yeah, let's go. Oh, now I just feel like a clown. Maybe if we had a mate or a robot to do this. I quit. Guys, what are you doing? Come on, I got it. I got it, Jeff, shut up. Okay, here we go.
Yeah, I don't know why I agree.
Okay, 1. All right, on 3.
Sweet, more packing materials. It's like when you pick up a turtle and it's like, we have to make sure we program this robot to be good, not evil. But we took out its battery, so it can no longer hurt us. The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.